Okay, I decided to do for 1C problem number 1, and that is prove the following statements assuming n is a natural number. And for a little note to self, the positive integers, which are whole numbers, 1, 2, 3, etc., those are natural numbers. So we'll start with A, and if n squared is odd, then n is odd. And to do this, I'm just going to use the numbers 1 through 10. So if n squared is odd, so we'll do n squared and then n. And these are for the odd numbers. So if n squared, so if n squared, so we're going to do 1. So if 1 squared equals 1. And we'll just keep continuing. 3 squared is 9. 5 squared is 25. 7 squared is 49. And 9 squared is 81. So if n squared is odd, which we have 1, 3, 5, 7, 9, then n is odd. So we just proved that if n squared is odd, then n is odd. Now we're going to do that for the same for B. So n squared and n, and these are the evens. So 2 squared is 4. 4 squared is 16. 6 squared is 36. 8 squared is 64. And 10 squared is 100. So here again we have if n squared is even, which goes to show 2, 4, 6, 8, 10, then n is even, which is true. So basically, anytime you times a number by itself, so if you times 2 by itself, or 2 squared, anytime you multiply 2 even numbers together, you're going to get an even. And anytime you multiply 2 odd numbers together, you're going to get an odd number. So that's how you do that problem.